Have you ever actually stopped to think about how the precise, rigid rules governing our entire universe are, well, they're the exact same rules keeping you alive? Breathing, moving, day in and day out? I mean, how exactly do the fundamental laws of the physical universe connect to something as visceral as the beating of a human heart? It's a massive, profound question. And today, we're going to go on this really fascinating journey to connect the dots between the macro world of physics and the incredibly complex micro world of human biology.
So, welcome to this explainer. Today, we're unpacking some seriously fascinating source material. We're looking at how precise physical rules and mathematical properties actually build the very foundation of living, breathing organisms. We're basically observing nature as this pragmatic set of rules. And as you'll see, understanding those rules is absolutely crucial to understanding ourselves.
Okay, let's lay out our roadmap for today. We're going to cover the scope of physics, precision in measurement, biological building blocks, fueling the body, and finally, deficiencies and disorders. All right, let's dive right into this.
Starting off with Section 1, the scope of physics.
So, physical quantities are generally split into two main buckets. On the left, we've got fundamental quantities, things like mass, length, and time. Think of these as the absolute baseline of reality. Then on the right, we have derived quantities, like volume or velocity. These are completely built by mathematically combining those fundamentals to, explain the complex world around us. It's like a giant puzzle, where the fundamental pieces snap together to create the whole picture.
Moving on to Section 2, precision in measurement.
Now, to really understand these physical quantities, we have to measure them with extreme accuracy. And to achieve this, we rely on instruments like the vernier caliper. The process is super precise. First, you place your object between the jaws. Then, you note the main scale reading, find the exact coinciding line on the vernier scale, and finally add them up for your total. But actually, there's a catch here. You absolutely have to account for what's called a zero error. Because if the tool's baseline is off, even just a tiny fraction to the right or left, you have to mathematically correct for it. Otherwise, that perfect precision, it's totally lost.
Which brings us to Section 3, biological building blocks. Let's transition from physical tools to the biological machines that make us up. Just as physical quantities build the universe, cells and tissues build the human body. We've got muscle tissue that handles contraction, and bone, whether it's super dense compact bone or the more porous spongy bone, acting as our structural support. Just think about the sheer physical mechanics at play here. Our skeletal muscles attach to these bones via tendons, and they essentially act as living, biological levers, pulling against the force of gravity every single time we move. It's incredible engineering.
But here's something really wild. Tissues aren't just solid, rigid structures. Take blood, for example. Blood is actually classified as a fluid connective tissue. Crazy, right? It's this complex suspension of plasma, red and white blood cells, and platelets. And the mechanics of this fluid are just mind-blowing. When you get a cut, exposure to the air instantly stimulates those platelets to produce an enzyme. That enzyme then grabs soluble plasma protein and weaves it into this insoluble network of fibers to clot the wound. It stops the bleeding and blocks pathogens. It is a highly precise, automated physical and chemical reaction happening right inside your veins.
Let's look at Section 4, fueling the body.
So just like any complex machine, our biological engine requires highly precise inputs to run correctly. Consider a simple glass of milk. Now, what's really interesting here is what happens beneath the surface. We all know it provides calcium for building dense bones, sure. But calcium is also a critical mineral that regulates metabolic functions and muscle movements. Literally, without enough calcium, your biological levers will start to seize up. It causes severe cramps that can rapidly progress into intense muscle spasms, a condition known as tetany. And alongside those minerals, we require precise inputs of vitamins, like the ones found abundantly in citrus fruits. If we don't have the right balance of elements, take iron for instance, the entire system suffers. A drop in blood oxygenation leads to extreme fatigue, shortness of breath. It's a perfect example of how lacking just one fundamental input can cascade into a total, system-wide failure.
Section 5, deficiencies and disorders. We have to pivot here to look at the devastating, systemic consequences when the body is deprived of these precise physical fuels. The sheer reality of severe malnutrition really anchors this mechanical breakdown visually. We're looking at two very distinct structural failures, kwashiorkor and marasmus. Marasmus, for instance, is a total energy deficiency. We're talking about a child's body weight dropping below 62% of what's expected. It is a heartbreaking, literal mechanical breakdown of the body from a total lack of fuel.
And this brilliantly illustrates the differences. Comparing the two directly reveals very specific, observable physical changes. Kwashiorkor typically presents with what's called a moon face and severe edema, which is fluid swelling. Marasmus, on the other hand, lacks that edema but causes extreme emaciation, thinning of fat, and severely low body weight. By observing these distinct physical changes, we can see exactly how the body's systems are failing at a structural level.
But, sometimes the breakdown isn't from a lack of external fuel. Sometimes it comes from internal inherited blueprints. Thalassemia is a prime example of this, and it actually ties right back to our earlier definition of blood as a connective tissue. It's a group of inherited conditions that directly affect blood hemoglobin. Basically, a person with this condition produces very little to no hemoglobin, which red blood cells desperately need to carry oxygen around the body. Because this fluid connective tissue just can't do its job, patients suffer from a pale appearance, poor appetite, slowed growth, jaundice, and even an enlarged spleen, liver, or heart.
As we wrap up this explainer, I really want you to think about this incredible interconnected web we've just explored. Seriously, it's all connected. The precise mathematical laws and fundamental quantities of physics, they're the exact same things governing the tension of your skeletal muscles and the fluid dynamics of your blood. The elements and minerals you consume physically construct your biological tissues. So I'm going to leave you with this question to ponder. From the smallest micrometer measurement on a vernier caliper to the calcium-rich foods sitting on your plate, how are the laws of science shaping your reality today? Keep observing, keep questioning, and I'll catch you next time.